you're done with the first quarter. So this is the start of the second quarter, section 4-1. We are going to be classifying triangles. Now, I have a little song for you. I'll sing it for you twice and only twice.
Why not 3 times?
Might I remind you that, let me just start off with the fact that my husband claims that I sound like a screeching cat when I sing, and Mrs. Nelson says I'm horrible. But other than that, I have no issues with my singing. I should have been a country music singer making lots of money, if only. I'm the next American Idol. How's that?
You should try out. I would vote for you.
All right. So when we classify triangles, they actually have a first name and a last name, just like you. You know that song, one of my favorite songs, is actually one of my favorite things to eat as a child was fried bologna sandwiches. If you've not had the joy of bologna, you've missed out on your childhood. Oh, the best thing ever. When you fry bologna, it puffs up like a little dome. Lots of grease, it's delicious. A little cheese in there, it's wonderful. Fantastic. It's like a little hot dog rolled out. It's terrific. Why do you think that sounds gross? It's delicious. So my point to you is this. Do you remember the Oscar Mayer Wiener song?
Yeah.
Okay. Da, 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 da. Well, that's what my song goes to. Are you ready? When we classify triangles, they have a first name and they have a last name. You have to name your triangles first name first, last name second, just like you. All right, so my triangle has a first name. It's A-N-G-L-E. My triangle has a second name. It's S-I-D. A couple extra U's in there. Oh, I love to name them every day. And if you ask me why, I'll say... Don't you think I should be on American Idol?
Definitely.
I love to name triangles in Mrs. Murray's geometry class.
Encore, encore.
Yeah,
You said you'd sing it
yeah, you're going to
twice.
record it and have it as your ringtone, right? Yeah. Just my geometry teacher singing.
Wait. Did you record this lesson yet?
I will. I'll sing it again in a minute, but
Are
just...
you recording this lesson?
Yes, I am.
Okay. Beautiful.
All right, so before we talk about the first and last name of a triangle, let's talk about the fact that a triangle belongs to the polygon family. Poly meaning many, gon meaning sides. So a polygon is a many-sided figure. The true technical definition of a polygon is that it is a closed figure with straight lines.
So it could be anything that has just one line.
So long as it's closed, there's no opening and there's no curves to it. So if you think about the outline of an ice cream cone that's in the delicious little waffle cones, I hate those little styrofoamy, whatever the other things. What do you call those cones? I don't know. The sugar cones are delicious.
Yes.
Anyway, it has a triangle to it, right? But it has the curve for the scoop of ice cream. That's not a polygon. Most of your pools, kidney shapes, whatever, they have curves to them, right? That's not a polygon. They're closed, but they're not polygons. What about the track outside on the football field? Is that a polygon?
No.
It's got a curve on either end, doesn't it? What about this room? Is this room a polygon? There are no curves to the room. And it has many sides.
This curve right here.
That's not a curve, it's a straight wall.
No, look, it goes that
No,
way to this way.
trust me, it's a straight line.
Definitely not.
Definitely is. Trust me, it's not rounded.
It's straight.
Connor, it is not rounded. All right.
Well, it's not straight.
It is too. I
No,
can't
it's
help.
not. Look, it goes like this. A straight line goes like that.
Or I could go this way.
Okay, I can't help bad construction practices, but let's assume it's perfectly straight. Okay.
It's not.
All right, now. So if my first name is A-N-G-L-E, we have to name triangles by their angles. So the first type of angle name is acute. So a triangle can be an acute triangle if all angles are acute. And so an acute triangle might look like this. You always need a straight edge for drawing in geometry. And so you might have 42 degrees here, 58 degrees here, and 80 degrees here. Okay, so there may not be exactly that, but you know, go with it. Aren't all those angle measures acute between 0 and 90 degrees? Okay, if all three angles are acute, it's an acute triangle. If any one of them is not acute, it's no longer an acute triangle. So then we could have an obtuse triangle. So if an angle is not acute in a triangle, it has to be obtuse. You cannot have a straight angle in a triangle. There's no way to make a closed figure with a straight angle. So that's out. Not with 3 lines. The line itself doesn't count as, we're talking about where the vertices are. So then you can have an obtuse triangle. An obtuse triangle just has one obtuse angle. And if you think about this, if I had 2 obtuse angles, let's say that my elbows were the bottom of my triangle right here. If I had 2 obtuse angles, doesn't it look like this? It's open, isn't it? There's no way you can have an obtuse angle here and an obtuse angle here. You'd have all this open space with only 3 sides. So you can only have 1 obtuse angle. The other 2 are going to be acute. So it might look like this. So this angle here might be 160 degrees. There's your obtuse angle. And then this one might be 15 degrees and 5 degrees. Again, what do the interior angles of a triangle add up to?
180.
180. So if you check those, they should be 180 degrees. So if it's not acute and it's not obtuse, what's another triangle? Right. So you can have a right triangle. How many right angles can you have?
1.
Just one. So 1 right angle. And so with your handy dandy grid paper, make 1 right angle. And don't forget, on your right angle, the 2 sides that make up the right angle are your legs. And according to Pythagoras' theorem, those legs are A and B. And the longest side is always across from that right angle. What's it called? Hypotenuse. It has the word pot in there, hypotenuse. Learn how to spell it. Yes, I thought that'd get your attention. And don't forget that Pythagoras' theorem, while we're at it, Pythagoras' theorem is a squared plus b squared equals c squared. Now, those are all of the angle names that we can have. There's also a triangle that we'll get to at the very end that has all equal angles. It's part of the acute triangle family, but if all 3 angles are equal, what would all 3 angles be? No, but if all 3 angles, what would be the measure of each angle? 60, 60, 60. Aren't those acute angles? So it does fall in the acute triangle category, but it's a special one, which we'll talk about in a minute. Can I flip this page?
Isn't it called an equilateral triangle?
No? I heard no? Okay, I'm going to pass this back down to you. Will you pass that back? All right, then we're going to get to the sides. You should have heard of these sides before. The first side is called scalene. So you can have a scalene triangle. And what does scalene mean? Anybody know? All sides are different lengths. So each side has a different measure. So here's how you would show what a scaling triangle looks like. And a scaling triangle can be obtuse, it can be acute, and it can be right. So if you're trying to show me that you've drawn a scaling triangle, you're going to have to use tick marks. So I'm going to use 1 tick mark on one side, 2 tick marks on a second side, and 3 on the third. When sides have different numbers of tick marks, it implies that they have different lengths. All right, then if we have 2 sides the same, what's that called? Isosceles. Isosceles has SOS in it. Isosceles. SOS. 2 sides have the same measure. So an isosceles triangle might look like this. And again, an isosceles triangle can be right, it can be acute, and it can be obtuse. So with your tick marks, you're going to show 2 sides with the same tick mark. I chose single tick marks for those sides. And then the third side should have a different tick mark. Now, there are parts to an isosceles triangle. I test you on the parts of the isosceles triangle. I would suggest that you learn them. Are you ready? Just like on a right triangle, we have legs. See the 2 sides that are exactly the same? These sides are called the legs of that isosceles triangle. The side that is a different length from the 2 sides that are the same is called the base. Just because it's called the base doesn't mean it's necessarily sitting on that base. Then the angle that the 2 sides that are equal create, this angle right here, is called the vertex. What you're going to find out on an isosceles triangle, the 2 angles that are across from the legs. Do you see how this angle is directly across from this leg?
Yeah.
If I were on this leg and wanted to hit the angle that's not part of this leg, there's only one angle left, this one. You're going to find out that this angle here, and I'm using 2 arc marks because generally it's a different measure than the vertex. You're going to find that it's the same as this leg here, the angle that's across from this leg. These 2 angles right here on the base are always going to be equal. Question?
Wouldn't it always be different from the vertex because if it wasn't different, it would be not isosceles?
Correct. If you have the same side lengths, the angles opposite those side lengths are always equal. So if I have a 60-60-60 triangle, all 3 sides are equal because all 3 interior angles are equal. So that's what Ricky was trying to say, which we're going to get to in just a minute. So in this case, these are called, these angles that are the same, this is called the base angle. And there are 2 base angles. You need to put this on a flashcard and learn it. Because I ask you to draw an isosceles triangle and label it on a quiz and a test or both. Have I not been true to my word up until now? And many of you have not taken me at heart, and you suffered mightily for that. All right.
Are the 2 base angles always next to the base?
The 2 base angles are always bordering the base, on either side of the base, always.
Okay.
All right, then the third triangle that we have is your equilateral. Equa meaning the same, lateral meaning side, so same sides. All 3 sides have the same measure. So here's your equilateral triangle. And to prove to me that you've drawn an equilateral triangle, what are you going to do with tick marks?
All the same tick marks.
Yeah, make them all the same tick marks. So I'm going to make them all single tick marks. That's telling you that they're all the same. In addition to that, because all sides are equal, what do you know about the angles? They're all the same as well. And so each angle measures 60 degrees. How did we get 60 degrees? Well, what's 180 divided by 3? 60. Technically, isn't an equilateral triangle an isosceles triangle? Aren't at least two sides equal on this one? So this is a special isosceles triangle. It's also a special acute triangle. If you were to name this triangle in this chapter and this chapter only, I expect you to name it by its first name and its last name. What's its first name? My triangle has a first name? Good. In acute, equilateral triangle. Or, oftentimes it's called an equiangular equilateral triangle. Equiangular meaning all angles are equal. So I will accept either answer for those. But if I ask you to draw an isosceles triangle and you draw this, I will mark you wrong. It'd be like me asking you to draw a rectangle and you drew a square. Although a square is a rectangle, it's not really what I asked for, is it? So for right now, you have I'll be specific and you need to follow those specifications. Okay. What if I had, let me put a triangle down here and you tell me what it's called. So here's example 1. I'm going to put several triangles down. We're going to name them. So here's the first one. Can a right triangle ever be an equilateral triangle? No, because it has a 90-degree angle, right? So here's just two examples, two triangles that we're going to name. Now I haven't put any arc marks for the angles in here, but you ought to be able to identify acute angles versus obtuse angles versus right angles, correct? Mm-hmm. Okay. What are you going to call this? Now again, let me just sing you my little song. My triangle has a first name, it's A-N-G-L-E. My triangle has a second name, it's S-I-D-E-E-E-E. Oh, please stop, put that thing down. You don't really want that, do you? Oh, I love to name them every day, and if you ask me what I'll say, I love to name triangles in Mrs. Murray's geometry class. There's your second shot at it. So, what's this called? What's its first name? Obtuse. What's its last name?
No. It's scalene.
It's scalene, right? Obtuse, scalene, triangle. So there's its first name, there's its last name. So don't name it in a scalene obtuse triangle. I'll mark you off for that. Scott? If you want to be technical, sure. Maybe. It depends on how I ask the question. But that's it's a triangle. I would put it there. What's this one called?
Right isosceles triangle.
Right. Why is it isosceles?
Because it's two angles.
Two sides that are equal. Right isosceles triangle. Okay? All right, then you're going to have some algebra problems associated with types of triangles, and your knowledge of these triangles have so many equal sides or so many equal angles. So you're going to have some algebra problems to set up regarding your knowledge of the name of the triangle and its angles. Remember, isosceles triangles have two equal angles and one that's not. Again, what do all three angles add up to? 180. So remember that the three angles in a triangle are supplementary. They all add up to that 180 degrees. Can I flip this? Want me to pass it back? Okay. All right, then, this is the only word problem we're going to do, but this is a type of problem that you might be given. Example 2. So example 2, triangle PQR is an equilateral triangle. Now something should be going through your brain at the mention that it's an equilateral triangle. What's going through your head? All three sides are equal, and you already know the angle measurements immediately. If I asked you to tell me what the angle measurements are of triangle PQR, there's no work to be shown, isn't it? 60, 60, 60?
Yeah.
So on that particular problem, I don't expect you to show work. All right, but this one says one side measures 2x plus 5, and another side measures x plus 35. Find the length of each side. Is this a word problem? So you have to do the 4-step plan. What is your let statement going to look like? What's your let statement going to look like? A blank is worth 1,000 words. A picture, right? What are we drawing a picture of? An equilateral triangle. Did I tell you which sides were which? Did I tell you which side was the x plus 35 and which was the 2x plus 5? No. Does it matter? No. Why does it not matter? Because they're all the same. So when I draw my picture, I'm going to draw my tick mark showing that all three sides are equal. And then you decide, and please label it as P, Q, and R because you were given those points. I don't know that PQ is 2x plus 5, but I'm going to let it be 2x plus 5 because it really doesn't matter. Isn't 2x plus 5 and the x plus 35, shouldn't they be equal? Okay, it's going to bother some of you that they don't physically look equal. But they're not going to look equal because it's an algebra problem. If they looked exactly alike, you'd have an identity. So what's your equation of solve going to look like? Yeah, so set them equal to each other because all sides are equal. Does it matter that we don't know what this side is? No, we only need two sides to set equal to each other. So can't we solve this problem here? So solve it over here. Do the algebra. Collect your variables first. Do not move the 35 and the 5. Move the variables first. I know. Did you get a value for x yet? Share it with your partner.
30.
There's your partner.
Oh, 30. Well,
I know. Question. No, because those aren't the angle measurements. Good question. But I don't know. I mean, I know what the angles are, but the angle measurements have nothing to do with the side measurements. Does that make sense? Okay. Does that make sense? Yeah. All right, so here we go. You should have gotten 30. You should have gotten 30. Notice I moved my x's first, not the numbers. And then how do you answer the question? The length of each side is 30 units, whatever those units are. If you don't practice the 4-step plan, you're going to have trouble on your quiz and your homework. So your homework is 16 through 43 all. Anything that's like this, that's a word problem, you need to do as 4-step. Question, Abby?